And so in many instances, when we did, lift and shift migrations over the past, 15 years, they weren't refactored to take advantage of the capabilities of the cloud that they're going to be hosted on. So in other words, they were just, moved from a LAMP stack or, my Windows NT on-prem into the cloud and kind of hope for the best. And without that refactoring, without the ability to kind of turn them into cloud native capabilities, they used up too many resources. So cloud native allows you to design applications specifically for cloud environments. They provide scalability, resilience, and they're easy to update. And as an attribute, they typically involve microservices, containers, APIs, and DevOps. Now, I know that's an ambiguous definition, but I think that's a good way to describe it. In other words, if something's built for the cloud, purpose-built for the cloud environment, typically it's going to be called cloud native. So how does cloud native work? Well, it emphasizes automation, elasticity, and rapid deployment. It relies on managed cloud services, infrastructure as code, and continuous delivery. So infrastructure as code means that we're able to bind configurations, which are going to be defined using code, to the particular workloads that we're working with in the cloud. And the idea there, it's able to declare how many resources it has, the processor it needs, the memory size it needs, the storage it needs, the IO it needs, the network bandwidth it needs to operate itself. And so by doing that, we allow these applications to have some autonomous capabilities. In other words, if they're able to define their own environments programmatically from within the application, that's a tremendous advantage.